Hello, and welcome to today's lesson, a review of matched pairs hypothesis testing. Okay, matched pairs is a very specific type. There will be some keys that you can see in a problem, either based on wording or based on the information given. Usually it's the information that's given that tips you off to a matched pairs. Okay, so normally we talk about data collection here, but let's look at the assumptions um, in a matched pair situation, because this is really going to be what tips you off to use this alternative method. Okay, you're going to be working through your standard assumptions, random, okay, should be stated in problem. Okay, you're trying to find that sentence and copy it down, basically word for word, as you're going through and verifying your assumptions. But in a matched pairs, it's the independent portion which is tipping you off to using a different method overall. Okay, normally when we're looking at independence, we're going to do n1 times 10 less than or equal to population size 1. So remember, we have sample size compared to population size. And we would do that for our second sample, n2 times 10 less than or equal to population 2. But all of a sudden, the second piece that we have to look at are the two samples independent of each other? And that's going to be your biggest tip here, is samples will be dependent on each other. Okay, in a lot of cases, it's going to be a pre-test, post-test, or testing two treatments on the same test subject. Okay, one of your tip-offs here is in almost all of these problems, you're given a table of values. Okay, so when you're given that table, you want to look at, oh, I'm given a table of information. I'm just not given mean value 1, mean value 2. Okay, look to see, are they independent? And as you're verifying your assumptions, okay, that's when you would make that choice about going to a matched pairs over a two sample. Then when we look at normal distribution, in a matched pairs, you're going to be working towards that worst case scenario, okay, because you're usually not going to be told that they're normally distributed. In a matched pairs, they're not going to give you a sample size over 30, which would allow you to use the central limit theorem. You're going to have to graph it, and what you're going to want to do is you're going to want to graph your difference values. Okay, so you're going to start doing your work on the front end for this test by finding the differences and then working through and using that single graph to test for normality. You're doing your box and whisker plot, and you're just verifying that there are no outliers and no extreme skew in that situation. Okay, now, so when we look at our number of samples in our hypotheses, okay, number one thing we want to do, read the problem. As we start checking those assumptions, verifying those assumptions, we're going to compute the differences of the samples. And then, once we have that single column, we're going to calculate one mean value, one standard deviation. Okay, and that is the difference between a matched pairs and a two-sample test. So when we state our null and alternative hypotheses, HO is going to be mu D, the mean value of the differences, equals 0, because we're always assuming that there is no difference between the two. And then the alternative is the mean difference is greater than, less than, or not equal to. Okay, always based on the context of the problem. Reading that last sentence, do they tell you greater than? Do they tell you less than? or do they leave it as a not equal to? And then we have to define what the mean difference is to finish up that problem. Okay, calculations. Once again, we're going to work through our calculations. A matched pairs is a single sample problem. Okay, it's going to be the x bar of the differences minus our parameter of 0 divided by our standard deviation of the differences over square root of n, and this is going to be a t statistic, okay, because we don't know the population standard deviation. We're working based off of our sample standard deviation. Now, worst case scenario, just work the problem like a 2 sample. You will lose a point for choosing the wrong type of test, but if you do everything else right, and we're more used to doing 2 samples, okay, you can still get a 3 out of 4 if you choose to do it as a 2 sample problem. You would state that right at the beginning. Okay, but if you can, you want to work at using proper procedure, matched pairs, of a single sample situation. So you have to show your t-value calculation with values. Then you're going to use your probability statement. Remember, you're not writing a calculator operation here. You're using your calculator to find that value, but you are not to write down a calculator operation. That's actually simpler to write the probability statement in that situation. And remember, this is the probability. If the null hypothesis is true of getting a result as extreme or more than what you found. Okay? And, some things. We're always thinking as soon as we do this, are we going to reject or fail to reject? And, one of the, tips or terms you can use is kind of a memory tool. If your p-value is low, reject HO. Is one of them. I always think of, is this probability rare? And if it's rare, you reject in those situations. Now, the conclusion is vital in a matched pair situation. You can do everything right, but if you use one piece of terminology wrong, you're going to get the same score as if you did a 2 sample and worked a 2 sample correctly. Okay, so the terminology, and when we talk about it, it's all about the context of your alternative statement. We talked about in the last video how you could use the formula sheet to help you with that conclusion, but now we have to do just a little something different. Okay, we are finding a mean value, but it's of the differences. Okay, and it has to talk about, your terminology has to match your calculation. We have a single mean value that's calculated based on differences. Okay, which is a lot different than a 2 sample. Notice in a 2 sample, it's one difference of multiple means. So you have to make sure that you're using the right terminology. Otherwise, all of your work in some ways goes for naught in choosing a matched pairs over a 2 sample situation. Okay, so now some extra practice on this. Your in-class packet, problem number 2 is a matched pairs example, so you can work through and complete that work.